The dehydration of alcohols, this produces an alkene. The mechanism is an elimination reaction. In terms of reaction conditions, you need hot concentrated sulfuric acid or concentrated phosphoric acid. Now let's take a look at the mechanism. So obviously we're taking an alcohol. In this case, I've got ethanol. There's a lone pair of electrons on the oxygen, which are donated to this hydrogen ion. Remember that hydrogen ion comes from the presence of the concentrated sulfuric acid. I just want to talk you through what's happening here. The electrons from this carbon-hydrogen bond are donated to form a double bond here. And because the oxygen has a positive charge, the electrons from the carbon-oxygen bond move towards the positively charged oxygen, meaning that the water is eliminated. So this is how we dehydrate our alcohol. We remove the water from it. After all, that's what dehydration means. So there's the water, and then we regenerate the H+, hence why the sulfuric acid is acting as a catalyst, because it is not used up. Now this method is actually becoming a more popular way of producing our alkenes, because remember they come from crude oil usually. Crude oil is a finite resource. The sugarcane used in fermentation, remember, is a renewable resource. This is why this method is becoming a more common way of producing alkenes. In terms of how this process actually takes place in a laboratory, it's through a distillation method. You're going to add your alcohol and concentrated acid to a flask. You're going to heat the mixture and collect the liquid that distills at temperatures below 100 degrees. You'll pour the distillate into a separating funnel and wash by shaking with sodium carbonate solution. Separating funnels are used to separate these immiscible, non-mixable liquids. The purpose of the sodium carbonate was to neutralize and remove the acid. Then we keep turning that separating funnel upside down. We open the tap, and that enables pressure to be released, prevents the stopper from blowing out. We then discard the aqueous layer and dry the final organic product using anhydrous calcium chloride. That anhydrous calcium chloride absorbs water and doesn't react with the alkene. And after product has dried, we remove the drying agent by filtration under reduced pressure, and this is done using a Buckner funnel and Buckner flask. I know that this method is very long, it's tedious, but unfortunately in the exam they could ask you very specific details, so it is worth writing this out on your flashcards or whatever revision technique you're using. Alcohol A undergoes reactions separately with acidified potassium dichromate 6 and with concentrated sulfuric acid. Deduce the IUPAC name for alcohol A. Do feel free to draw it out. I'm just going to pop it here. So count the number of carbons. 1, 2, 3, 4. So we're going to have butane. Check the functional groups. We have an alcohol here. Notice there's methyl attached here. The alcohol takes priority, so we're going to say that that's on the second carbon, which means that if we count that as the first carbon, second, third, it's 3-methyl butanol. Draw the structure of the organic product B formed when A is oxidized in the reaction with acidified potassium dichromate 6. I'm just going to bring back that structure actually so you can see it a bit more clearly. Have a look, count the number of carbons that the alcohol carbon is attached to. It's 2, so it's a secondary alcohol. Remember, secondary alcohols are oxidized to form ketones, but you can also see, look, the alcohol functional group is attached here, so the only thing that makes sense is for this to turn into a double bond O, giving us the functional group of a ketone as opposed to an aldehyde. So I'm just going to alter this. So that's done. 2 isomeric alkenes, C and D, are formed when A is dehydrated in the reaction with concentrated sulfuric acid. Name the mechanism. Remember, that is elimination when you're dehydrating an alcohol. Draw the structure of each isomer. So remember, when you dehydrate, you produce an alkene. I have got my structure of A back here again, so we just need to work out where that double bond is going to form. Remember, we lose water. It therefore makes sense that the double bond forms here or here. Name the type of structural isomerism shown by C and D. You can see here that the only difference between these isomers is the location of the functional group. That means that this is a position isomer. List alcohol A, product B, and isomer C in order of increasing boiling point. So alcohol A here, remember, is the secondary alcohol. Here's a ketone, and then we have an alkene. Remember, the alkene will have the lowest boiling point because it's only got van der Waals forces. So it will be C followed by our ketone. That ketone here, remember, has dipole-dipole forces, so that's why they're stronger than the van der Waals forces found in the alkene. But then the alcohol, A, over here, remember that has hydrogen bonding, which is the strongest of the intermolecular forces. Draw the structure of the isomer of A that is not oxidized by acidified potassium dichromate. So you're after a tertiary alcohol. Let's just steal this structure here, this displayed formula. So I need to rearrange the atoms to form a tertiary alcohol. So here is our tertiary alcohol. Look, it's tertiary because the alcohol group is attached to a carbon that itself is attached to 3 other carbons. Tertiary alcohols, remember, can't be oxidized by acidified potassium dichromate 6. And then finally, draw the structure of the isomer of A that cannot be dehydrated to form an alkene by reaction with concentrated sulfuric acid. I've drawn out the answer here. This is a difficult one because you need to think about what happens in order to eliminate the water. And if you look back at the mechanism I drew for elimination, you'll realise that the adjacent carbon to the one with the alcohol functional group must have a hydrogen attached, so that hydrogen carbon bond can donate its electrons to form the carbon-carbon double bond. Because this carbon here has no single hydrogen attached to it, we don't have all the necessary components required for an elimination reaction to occur.